All right, let's just jump right in. There's this argument that has been going around the web dev community forever, and it usually kicks off with this simple and honestly pretty misleading idea about React and performance. Today, we're going to unravel that whole thing.
I bet you've heard this, right? Or hey, maybe you've even thought it yourself. It's a killer hook because it just sounds so right. The company that made the tool has a slow product, so the tool must be slow. It's a super compelling story. But I'm here to tell you, it's the completely wrong story.
You see, that statement connects two facts. Yep, Facebook can feel slow, and yep, Facebook built React. But the conclusion it draws misses the real villain entirely. This has never been a React problem. It's a product complexity problem.
So here's the deal. The slowness you might feel on a huge site isn't a symptom of the UI library. No way. It's a symptom of just staggering, almost unbelievable product complexity that's been piling up for more than a decade.
This slide really pulls back the curtain. When you load a site like Facebook, you're not just loading a user interface. You are loading an entire ecosystem where every single item is a tax on performance. Every tracking script, every little piece of personalization logic, all the ad infrastructure, it all adds network requests. It all blocks the main thread, and it's all fighting for resources before a single React component even thinks about rendering.
And this, right here, this is the mental shift we all need to make. Asking is React slow is like asking if a wrench is slow. It's just the wrong question. The real question, the one we should be asking is, what are we actually building? And is the complexity of the product the real bottleneck?
You know, this whole complexity issue also shines a big bright light on a deeper architectural choice that often gets incorrectly blamed on frameworks. And it's all about where your app's brain really lives. Is it on the server, or is it on the client?
So in the classic model, the server is the absolute authority. It decides everything you see and everything you can do. Let's say you don't have permission to see a delete button. Well, the server just doesn't send the HTML for it. Simple. The logic is all in one place, and the UI is just a direct reflection of whatever the server says. It's clean, it's authoritative.
Now, let's compare that to the modern single-page app, which is a client-driven model. Here, the client gets a blob of data and then decides how to render the UI. This is amazing for creating those rich, super interactive experiences we all love, but it comes with a fundamental challenge. Remember that delete button logic? Now, it has to exist on the client to know whether to show or hide the button, and it has to exist on the server to actually, enforce the action. That duplication, that's not a React bug. It's a core feature of this entire way of building apps.
So even if we embrace the client-driven world, we have to get one thing straight. Performance is a discipline. It's not some feature you get for free. Frameworks like React give us incredibly powerful tools, but those exact same tools can create some really subtle, really dangerous performance traps if you're not careful.
Let's talk about the infamous use effect hook. It seems so simple, right? Hey, after the component renders, just do this thing. But what happens if this thing is something that updates the state that the effect depends on? If you're not super careful with your dependency array, boom, you've just created an invisible, performance-destroying infinite loop. The component renders, the effect runs, it updates the state, which triggers another render, and on it goes. That's not React being slow. That's the hidden complexity of managing side effects.
And that leads us to a kind of uncomfortable truth. React was never, ever built primarily to be the fastest rendering engine on the planet. It was built to solve organizational complexity. How to get hundreds or even thousands of engineers to build a consistent and predictable UI. It optimizes for the scalability of teams, not for squeezing out every last millisecond of performance. If you want raw speed, well, that's on you, the developer.
Okay, so if we stop blaming the framework and we start taking responsibility for performance, how should we even think about it? Let's walk through a really powerful new mental model.
This right here is the core idea. The most critical thing for your user is to see something useful and interactive, like right now. Think about it like a digital map. You don't need the entire world loaded at once. You just need the part of the map you're looking at. The user is going to take a moment, often a full second or even more, to figure out what to do next. And that little pause, that's a golden opportunity for us to load everything else.
So what does instant actually feel like? The goal is under 100 milliseconds. That's your total budget for all the JavaScript parsing, compiling, and rendering before a user can actually interact with your app. If you go over that, the app feels sluggish, it feels janky. The human brain literally perceives the delay.
So how in the world do you stay under that 100 millisecond budget? By being absolutely ruthless with your initial payload.
Your goal should be to fit everything, and I mean everything, needed for that first interactive paint inside the very first network packet. And because of how TCP works, that budget is about 14 kilobytes. That's it. We're talking bare bones HTML, critical CSS, and just a tiny sliver of JavaScript to get things moving.
And this table just lays it all out. The difference is stark. A typical single-page app might ship hundreds of kilobytes and immediately just choke the main thread with hydration. But the instant map approach, it is laser-focused on that tiny, sub-14 KB initial payload. Anything that's not absolutely essential gets kicked over to a web worker running on a completely separate thread so it doesn't freeze the UI. It's a fundamental shift, moving from just organizing our code to obsessing over the user's perceived performance, and that is how you get to interactive in under 100 milliseconds.
So after going through all of this, from product complexity and architectural choices, all the way to this new mental model for performance, it really all boils down to one final, really important question.
And that right there is the real takeaway. It is so easy to get lost in the weeds, arguing about patterns and libraries, but none of that matters if your user is just staring at a blank screen waiting. True performance engineering isn't about blaming a tool, it's about obsessing over that first critical interaction. So the question isn't whether your framework is fast enough. The real question is, are you building for your framework, or are you building for your user's first 100 milliseconds?